Thank you so much again for the opportunity to speak. And so today I'll be talking to you about the assessment of undergraduate experiential learning in microbiology labs. And so at NC State, in the microbiology curriculum, it's a little unique because it's the only BS degree for microbiology in North Carolina. And so we get to offer a really unique series of courses, including some microbiology cures. And so this work is focusing on two of the cures that are offered, a 200-level bacteriophage discovery and a 300-level discovery of antibiotic-producing bacteria. Others who have already talked about C phages and tiny earth, which is what these are. And the class is designed to really focus on the facets of the cure. And so students learn scientific practices, they discover novel findings. We talk about the broader impacts. They collaborate with one another and share. And then there's a lot of iteration and, again, a theme of failure and how students learn from failure as part of the scientific process. So these courses are assessed. So the students are graded on quizzes. There are weekly reflections where they think about their progress in the lab and they comment on that. There's a lab notebook, and then there's a poster and a presentation. But what I wanted to do is figure out what the effect of the courses at NC State are on student research skills and scientific identity. And so to do this, I used a pre and post-course survey. So I'm really assessing what the students are getting from this. And there was 26 questions and 38 Likert and short answer questions in the surveys. I used already published surveys to get at what the students were learning in terms of skills and scientific identity. And so the culture of scientific research, Dr. Brownell's work with the expanded experimental design ability tool, and then perceptions of an undergraduate scientist tool. And today I'll be focusing on the culture of scientific research and perceptions because that's the data that I have some preliminary results for. I also want to point out that the N is 4. It's very small. Despite incentivizing this survey with a few points, not many, only 4 completed both the pre and the post. I think all students completed some version of it, but I need both. So yeah. And so when we're thinking about the culture of scientific research, and so I asked them if they're interested in obtaining undergraduate research experience. So kind of what are their academic goals? And before, 100% of them said they were, and after, only 75%, again with an N of 4. And so we're seeing that this class is shaping their goals. And then I asked them if they'd done research at NC State. And before this, 100% of them said no. So they were new to research. And after, 75% said yes, which is a little bit interesting because this class is research-based. When I asked them, what does it mean to think like a scientist? They said it means to be inquisitive. And so after, they talked about some of these facets of the cure, to question everything, to form hypotheses, and then pursue even after failure, which was really encouraging to see this deeper answer. When I asked, what does it mean to do science? Some examples are to seek answers to questions and not giving up, and after, to make a hypothesis and an observation and attempt to prove it using evidence, so the scientific method. I also asked, is a cure real research? And so would you call this real research? 100% of them said yes. And in one of their free responses describing why they felt this way, they're pulling out some of these components, again, of the cure. So it's true discovery. Not everyone gets the same results. Not everything resulted in success. So there's iteration as a part of that. And then they presented unique results. And so there's that collaboration and communication piece at the end. Next, when we're thinking about the culture of science, this was really important to me to understand how students feel about their abilities and how they identify as scientists. And so there's both pre and post data for these questions in terms of their confidence for scientific skills. And so interpreting data based on experiments increased. And so more felt confident after, which is great. And so these cures are giving them the ability to interpret. For all of these, we saw some increases. And so students were able to communicate their results. And then students were able to use some scientific language, and they were able to use technical skills. And that increased a lot after this course. For scientific identity, There were a lot of questions answered, but in the interest of time, we'll focus on a couple. So most, and this was only post, but most students felt that the experience taught them very valuable skills, which is helpful again. CURE is allowing them to increase their understanding of scientific skills, scientific experiments, and how to carry them out. They also felt that they were responsible for the outcomes of the lab. So they're taking ownership of what's being done. And it's not just a lab where they come in, they get the answer, and they leave, which is encouraging. And then the results that they obtained gave them a sense of personal achievement. While not all strongly agreed, they were able to put ownership as part of this experiment, which experience, which is really important when you're considering the scientific process and being a scientist. So for future directions, I still need to analyze the expanded EDAT survey responses, and this needs to be done with 2 people independently, and then we'll come together. And then again, that's a very small N, and so we're going to collect and analyze future course responses in additional offerings of these courses. And so I realized that was pretty quick, but in the interest of time, this is what I was assessing and hope to show that this environment is helping students. And if not, it gives us the ability to go back and change and modify so that we can help students understand what science is like and increase their scientific identity. And so I'd be happy to answer your questions in the chat if that's appropriate, or other ways. But the slides are available with the QR code, and you're always welcome to send me an email as well. Thanks so much.
Great, thank you. You were actually perfectly on time. And there is so far one question in the chat. The question is, for the post answer, do you ever discuss how experiments not prove hypotheses or theories? They only challenge them.
Yeah. Good, yeah. So we have some conversations about how to generate hypotheses, but I will admit that we probably need to work on that more for these classes. There's a pretty good research flow in terms of like what you're doing next. And so the hypotheses are often driven by that rather than them making their own, as some of the examples. But that's a good thing to have them think about more. Thank you.